Okay, taking a look at this problem, what we see here is we want to do partial fraction decomposition. So just first consider the fraction 1 over 16 minus 25x squared. You'll want to factor the denominator as the difference of two squares. So it's 4 minus 5x times 4 plus 5x. So those are your linear factors. So you can split your fraction up then, and so you can write 1 divided by 16 minus 25x squared as a over the first linear factor plus b over the second linear factor. All right, and then if you cross multiply by that that product, if you multiply through by the 16 minus 25x squared, so that's kind of, you can think of it the same as multiplying by 4 minus 5x times 4 plus 5x. You'll get 1 equals, this will be a, and you'll have 4 plus 5x left there, because this factors, you remember, this factors as the 4 minus 5x times 4 plus 5x. So when you multiply it through, those cancel. Those will cancel with that. And then when you multiply through here, you're going to get b times the 4 plus 5x's are going to cancel, so you'll have the 4 minus 5x left. Okay. And then there's lots of ways to solve this. You can go through and set up a system of equations, but I think the easiest way is to figure out what makes one of those linear factors equal to 0. So if you have 4 plus 5x and you set that equal to 0, then you'll get x equals negative 4/5. So if you let x equal negative 4/5 and you plug it in, you're going to get 1 is equal to a times 4 plus 5 times negative 4/5. Plus the b times 4 minus 5 times negative 4/5. And then the 5's cancel here, and so that actually is going to, 4 plus 4 is 0, so that's going to be 0. So the a term is going to cancel out, and then you'll get 1 is equal to, here the 5's cancel, but you'll have negative 4 minus 4, which is 8, so you'll have 8b. And so that leads you to, if you divide 3 by 8, you'll get b is equal to 1/8. And then you can do the same thing if you let, let's 4 minus 5x equals 0. So looking at the factor in front of the b, or next to the b, then that would make x equal to positive 4/5. And you should be able to convince yourself then that you'll have 1 equals a times 4 plus 5 times 4/5. And then when you put that in here, you're just going to get 0. When you put 4/5 in there, you'll get 0, because 5 times 4/5 is going to be 4, and then 4 minus 4 is 0. So that term will 0 out, and then you'll get 8a here. Oops. And so then you'll find that a is equal to 1/8 also. So you could rewrite this, the whole idea, this is just the partial fraction decomposition. So that means that you can write this fraction 1 over 16 minus 25x squared as, because the 1/8 is common to both of them, I'm going to factor it out. So it's 1/8 times 1 over our 4 minus 5x plus 1 over 4 plus 5x, which will be easier to integrate. So now we'll consider the integral of 1 over 16 minus 25x squared dx. that will be equal to 1/8 times the integral of 1/4 minus 5x plus 1/4 plus 5x dx. And then you'll want to do u substitutions for each of those. So if you let u equal 4 minus 5x, then du is equal to negative 5 dx. So then you'll get negative 1/5 du is equal to dx on that first one. And then on the second one, similarly, if you let u equal 4 plus 5x, then du will be positive 5x dx, positive 5 dx. And then 1/5 du will equal dx. So we can come in here and we can think of this as the 1/8, and then we'll have the integral of negative 1/5 times 1/u plus 1/5 times 1/u. And then you have the du on each of them. So I guess if you want to think of them separately, you can. You put a du here, and this integral with a du here, because the u's represent different things. But then, of course, 1/u, the integral of 1/u is just ln absolute value of u. So you'll have the 1/8, and then the integral of this will be, sorry about my voice, negative 1/5 ln absolute value of u. But in this case, the u was this value. So that's going to be 4 minus 5x. Plus, you'll have positive 1/5. And then this will be the ln of the u, which in this case was the 4 plus 5x. So absolute value 4 plus 5x. And then at this point, to clean this up, you can make this a little fancier using properties of logarithms. For example, if you were to factor out the 1/5 and then rearrange it so it's a logarithm minus the other logarithm, you would get 1/8 times 1/5, which is 1/40th. And then I'm going to switch the order here. So I'm going to have ln of absolute value of 4 plus 5x minus the ln of the absolute value of 4 minus 5x. And the reason I did that, because then I can use, remember, the ln of a minus b is the ln of a divided by b. So this will be 1/40th the ln of the absolute value of 4 plus 5x divided by the 4 minus 5x, and then plus c, which is the answer that I tried and they took. When I typed it in, I had this parenthesis and just left it and they took it. The real thing that you have to be careful is you do need to make sure you're taking the absolute value when you're taking a natural log. So hopefully that helps.